Solar storm Havoc. Russia suffers long-lasting radio blackouts as solar particles batter our Earth. The solar storm that struck our Earth inbound on February 2nd, the atmosphere has caused chaos to Russian radio signals with periods of blackouts. The coronal mass ejection CME blasted out the sun's layer January 29, sending with its fast solar winds geomagnetic storm that catapulted into Earth's atmosphere yesterday, February 3rd. The 2nd to the 3rd is when this came in yesterday. The storms bring billions of tons of fast-moving solar particles from these coronal mass ejections, as well as magnetic fields that blinds them. And when these crash into our Earth's atmosphere, it can cause chaos down below, including the chance of radio blackouts. This is exactly what happened. These cause problems in intrusive and long-lasting ways, and it now appears that the ongoing solar storm has caused this issue for Russia. Space weather physicist Tamitha Skov wrote in her Twitter, here's what aurora from ongoing solar storm is doing to VHF radio in Russia. This is why solar storms often impact amateur radio in an intrusive and long-lasting way. Ms. Skov shared the audio clip of the Russian radio in which the solar winds could be heard interfering with the broadcast, but this comes at a time when there are reports that 100,000 Russians are at the Ukrainian border. Now, Space Weather Center SWPC ranks solar storms on scale of G1 minor, the least intense, all the way to G5. This was supposedly a G2. Now, even the weaker solar storms are able to interrupt radio communications with the high energy radiation that they can bring. This radiation is said to cover the entire electromagnetic spectrum. Elements like ultraviolet and X-rays will cause changes to the Earth's ionosphere. That's the upper part of the Earth's atmosphere, and it will result in these radio communication issues. It heats up the atmosphere up there and alters the radio communication, the radio waves. The Met Office Space Weather Forecast said of the CME launched from the sun January 29, early indications show that minor geomagnetic storm levels were reached, but subsequent data from British Geological Society showed that, in fact, moderate geomagnetic storm levels were reached with unsettled to active conditions following for the rest of the day. When solar storms are stronger, they can cause even more disruption. According to space weather, when CMEs collide with Earth's magnetosphere, all of that extra radiation can damage the satellites we use for communications and navigations. It can disrupt power grids that provide our electricity. And this can lead to power outages that could even last for days if solar storms are at their strongest. But even the weakest of storms threaten power grid fluctuations and have a minor impact on satellite operations. And of course, there are also radio blackouts. And the Met Office warned that the storm is not over yet. The website says solar winds will probably remain elevated for much of today, with a chance of briefly becoming strong. That's today. And tomorrow, the 5th, the solar wind may temporarily decrease to slightly elevated levels before returning to elevated levels. It warned that there's also a chance, 30% chance, of a minor storm interval today, and also a 20%, but especially tomorrow, 50%. So they're still coming in. This is by Jacob Paul on Express UK. Let's take a look at space weather, what's going on. This is space weather, and these are the new sunspots. AR 2941 could be the leading member of a much larger group, particularly partially eclipsed by the edge of the sun. Helioseismology of the sun's far side detected the group last week. So, minor geomagnetic storm in progress is still going on. A minor G1 class geomagnetic storm progress today, and as we said, it's going to go on tomorrow. This is from the flare that came out on the 29th. As Earth enters a region of south pointing B sub Z, this could be a lingering after effect of the coronal mass ejection impact late February 1st. And this is the B sub Z tips south This is our solar wind. This is Earth and Earth magnetosphere, magnetic field. The sun is a big magnet, and our star has an internal dynamo that generates a strong magnetic field. The solar wind carries this magnetic field throughout the solar system. Earth also has a magnetic field. It forms a bubble around our planet called the magnetosphere, which deflects solar wind gusts, and here they're deflected. Earth's magnetic field and the sun's magnetic field come into contact at the magnetopause right here, okay? A place where the magnetosphere meets the solar winds. Earth's magnetic field points north at the magnetopause. If the sun's magnetic field points south, a condition scientists call southward BZ. Then the sun's magnetic field can partially cancel Earth's magnetic field at the point of contact. Okay, so when BZ is south, that is opposite Earth's magnetic field, the two fields link up, and you can then follow a field line from Earth directly into the solar wind and eventually back to the sun. South pointing BZs open a crack through which energy from the sun, solar wind, can reach Earth's atmosphere. Obviously, that's not good. Okay. South pointing BZs often herald widespread auroras triggered by solar wind gusts or coronal mass ejections that are able to inject energy into the planet's magnetosphere. And back to space weather again. There we are. We're into a solar cycle of 25, so we're getting more solar activity. For much of the past year, space weather community has been buzzing about the strong performance of the young solar cycle 25. Every month, sunspots seem to blow past official predictions. This means we're about to have a strong solar maximum, right? Not so fast, though, says Dr. Ron Turner, analyst at the Answer Research Institute, Virginia. It may be too early to anticipate a strong solar cycle. So here we are. This was the minimum, and now we're going to the solar maximum. And this is a solar cycle that happens every 11 years. Solar cycle 25, doing something interesting. It's mimicking old solar cycle 24, which is here. Okay, Turner says, I took sunspot numbers from the early years of solar cycle 24, the red dash line, and overlaid them on solar cycle 25. They are almost perfect match, he says. This is significant because solar cycle 24 went on to become the weakest solar cycle in the century. Its hot start did not lead to the strong maximum. Turner said it's saying that solar cycle 25 will likely be a dud, but rather these early sunspot numbers are not enough to guarantee a strong cycle. Deja vu anyway, he says. And these are the beautiful auroras that we see. February 3rd, a crack opened in Earth's magnetic field. Solar wind rushed in to fuel display of auroras across the northern U.S. states. And this is our beautiful aurora over Wyoming, Sheridan, Wyoming, by Kevin Palmer. This is beautiful, isn't it? Beautiful. He says, I had low expectations of seeing any auroras, but they became very bright at 1:30 a.m. Mountain time. Palmer says the view was worth enduring the sub-zero temperatures. And we also had auroras in Minnesota and Washington. The crack was the after effect of the CME impact February 1st. South-pointing magnetic fields in the wake of CME often pry open such cracks, leading to auroras hours to days after the CME passes us. And these are just the fireballs that we had today, 7 fireballs. And color-coded by velocity, red meaning slow to blue meaning fast. So all of you there, please be very aware. If you want to watch the auroras, you can probably still see them today and tomorrow if you're at the border, US and Canada. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support, and that you find all my content so interesting. You'll find the Patreon account details in the description box.